Good afternoon, everyone. Welcome back to my channel. Uh, so, in today's video, we'll be dealing some mathematics, and the topic is D operator, right? Operator D notation. Yes, operator D notation. Actually, we did some prerequisite video to this course, but so in this course we'll be dealing with what a D operator, and this course is mainly on uh, differentiation and what integration. So instead of showing you differentiation and integration, then you will be seeing D operator and what inverse D operator. Right now, when you say the D, is mainly still talking about what differentiation, but for this D operator, we are trying to restrict it to just to dy dx, right? Dy dx. So it means if we are d of any example, then it means we are simply differentiating that example with respect to x, right? Now, before we start, we have some constant formula that you already know in normal differentiation, because we have done a video before this video. So if you have not watched that video on the yes, on partial differentiation, on partial differential equation, try to watch that video. And also for this video, for this course, the operator we having like 45 slides. So because of time, we try to split this class into two classes. So you have the first video, which is this, and when we get to slide 20, we try to do another video, at least to make the two videos short, not too long. So we have somewhat different differentiation formulas, as you can see on the screen. I will advise you just pause and go through them, because we have already explained most of them. So it's better you just stop and go through them, although we are going to explain some of them, some of the basics that you need. Like looking at this, we have the sum rule. When you have an example like this, then uh, it means you are differentiating it on individual basis. But for D operator now, instead of you seeing du dx, it means you just see D. You see capital letter D, then with what a curly bracket, right? Then you have product rule also. So instead of having D and ds, it means you just see what is simple D. And definitely is what a product rule, and this is what the formula for a product rule. So also we have some other derivatives. You can pause the video and go through them. Now for the D operator, we recall that whenever we want to differentiate x to the power of what n, the basic formula is that we have n minus 1, then this n will come and what multiply what this number that we are what differentiating, right? So we have n x to the power of what, then you reduce this by 1. That is normal differentiation that we know. And also we have e to the power of what, kx, then differentiating this, then it means we have to differentiate, let's say function of a function. You differentiate this entirely, it will still give you this, which is this. Then differentiate ks, which will give you k, then use it what to multiply it, then we have this. Then when differentiating sine x, then it will give you cos s. All right. Now, in the derivative of the function, this is replaced by what? D. So instead of having d dx, we are simply what replacing it with what? With a simple d. So the letter d to indicate the same operation. Therefore, we can write, so when we say d of what, x to the power of n, so it's the same thing that you are simply differentiating it. Right? So it means for this, we have my n here, which will come down to multiply this and this we have, then I will reduce it, what, reduce the power by 1. Then for e the power of kx is still the same thing, just like differentiation of what sine x, it is the same thing. So in this case, it simply means differentiation, which is what the d simply means what, differentiation. This one is just trying to reduce the complexity of some of what the equation that we may what encounter. So the same when we are talking about the operator, we simply apply what the differentiation row. Now, example 1, we are to simplify, we have d, then open bracket, we have 2x squared plus 10x plus 5, right? Now, with this, is very simple. What you do, uh, just simply use this my d to open each of, because normally say if you have a function of this and you have the x here, it means you are differentiating everything. So it means you just apply what a chain rule to it. You differentiate this with respect to s, differentiate this with respect to s, differentiate this with respect to s. Now since I'm using what my d operator, I can what, I should what, open the bracket first. So I have this, so this which will give me this, I have this to this, which is what this, and I have d to 5, which is what this. So whenever I differentiate this with respect to x, it will give me what, this multiplied by this give me 4, then I reduce this by 1, so we have 4x, right? Then when I differentiate this, I have 10x, yes, 1 here, 1 come to multiply 10, still I have what, 10, then I reduce this by 1, then it means I have 10. And whenever I differentiate a function, a constant, it's always what, 0. So it means the d operator of this is simply what, 4x plus 10. Then I have another example also to simplify d square. Now this square is now telling you that this is second order differential what, equation, or second order differentiation. So it means you have to differentiate this with respect to s twice, right? Then now, so the first thing is, well, okay, I rewrite it, so I have 2s cubed. Then this, so I can decide to what, to simplify it like this. One this outside, then inside bracket I have another d. So I will differentiate this with respect to s. It will give me 6s squared, right? Because I'll come here, 3 multiplied by 2, 6. Then I'll reduce this by 1. So we have this. Then I will differentiate it again with the last d, because I said second order. Then it means, then here we have what, to multiply by 6, which will give me 12, then reduce this by 1. So we have what, 12x. Then I have another example here. I have what, this square also, which means was second order differentiation. I have what, 5 sine x plus cos 4x. Then the first thing is that we have 2d. I can decide to break it down now. 1d, then 1d with this. So I will differentiate this 5 sine x will give me what, 5 cos s. Then I will differentiate this, differentiation of cos s will give me minus sine x, right? Then it means I should have what, differentiating cos 4s will give me sine 4x. Then I will differentiate this, which will give me what, 4. So I will multiply this. So it means I have removed one order. Then I will differentiate this again for the second order. So 5 cos s, if I differentiate cos s, it will give me minus. So 5 cos s will give me what, minus 5 sine x. Then differentiating 4 sine 4x, it means it will give me, my 4 will be there. Then I will differentiate sine 4x, which will give me cos 4x, right? Then differentiate 4x, it will give me 4 multiplied by 4. Then I will have what, 16. So it means the second order derivative of this is minus 5 sine x minus 16 cos 4x. Then here I will so to simplify this also. Now for this I have d plus 6 open bracket, then e to the power of what, 3x. So what you do is that you open this bracket just like the way you solve what, your algebraic equations and other. You open this bracket so that this can simply what, multiply everything here. So it means I should have what, d the power of what, d is now multiplied by e to the power of what, 3x plus, then 6 is multiplying what, this. Then looking at this, d is differentiating this, it means I should differentiate this. So differentiating this, e to the power of 3x will give me what, if I differentiate it to give me what, e to the power of 3x. Then I will differentiate 3x, so I will have this. For this, there is no d. So since there is no d, then it means I'm not going to differentiate it. I simply want to open the bracket to give me this. Now there's something common here, which is what, e to the power of 3, or I can just add them. 3 e to the power of 3x plus 6 e to the power of 3x, add them, it will give me what, 9 e to the power of what, 3x. Now I have another question, which is what, d plus 3 square sine x, right? But Now the simple thing to just do is that, normally I'm supposed to open this bracket then to know which terms I'm actually supposed to differentiate because of what the d that is here. So looking at this, you simply apply what algebraic, right? Apply what algebraic process. So d plus 3 square is same as what? D square plus 6d plus 9, right? Is the same as what? Because this will give you what? D plus 3, open bracket, then d plus 3, which is what you are multiplying d plus 3 with d plus 3, which will give me this. Then I have what? My sine x. Then I will open this bracket. This is multiplying this to give this to this, you give this to this, it will give this. Now it means for my sine x I will have to differentiate it in the second order. Why for this is just d, so I'm differentiating it in the first order, but this is not having any d at all. So I will differentiate this sine x to give me cos s, so I still have 1d, plus I will differentiate sine x, it will give me cos x, then multiply by 6, then plus d here, there's no d here, so I'll leave it what like that. So we should give me what? 9 sine x, right? Then I'll differentiate this again to give me minus sine x, right? Plus I will differentiate this, I will differentiate cos s, so sorry, it's supposed to give me minus sine x, right? Oh, sorry, there's no d here again, which means I simply have a plus 6 cos s, because there's no d, so I'm not going to differentiate it. Then plus here I have what? 9 sine x, so it will give me this. So here it means I have minus sine x plus 6 cos s plus 9 sine x. Look at sine x, negative sine x, then here I have what? 9 sine x. So adding this together, it will give me what? 8 sine x plus 6 cos s. Now the main advantage of this operation is that you can manipulate it algebraically, right? You can manipulate it each algebraically. So when you instead of having d dx, or you will now be having maybe d dx plus 3 then square, it may be difficult, but with this d operator it would simplify it. So we have some examples or some exercise that you are going to go through. You can go through them. Whenever you have any question, you can comment in the comment section, or you can simply drop your answer on the comment section so that we can verify if your answers are correct. But this is still simple. You have second order, so it means you are differentiating this and differentiating this and what differentiating this in what second what order. Then just like that. Now also we have what is called what the inverse operator, right? For the inverse operator is inverse d operator, right? Is 1 all over d, which is just the same thing as the inverse of what differentiation is integration. So it means for my inverse d operator, it means I should just what integrate, right? Since d indicate differentiation, therefore 1 all over d supposed to indicate what integration. Then note the inverse operator denote integration with respect to x. So in this case, the arbitrary constant of integration is omitted. So instead for you showing what integration, you simply will see what 1 all over d. So the first example here, we have what 1 all over d, which is what integration. Then we have x plus 1 all over x, right? So for something like this to you can simply use this to open the bracket. So 1 all over d is covering this, then 1 all over d is what covering this again. And also when you integrate this, it will give me what for integration. Don't forget the simple formula is that we have what x to the power of what n plus 1, then divide by what n, if my n is what the power, right? So from here, x to the power of 1, then it means I will have 1 plus 1, which will give me 2, then I will divide by this power. Then plus, so the 1 all over d of what 1 all over x is what is simple, is what ln x, which is what the integration of 1 all over x is ln x. Then we have another example. We have 1 all over d to the power of 2. So we have what sine 3x minus 2 cos x, right? So the solution is that this we cover this, and this is also we cover this. Now 1 all over d square is just talking about you have to integrate in the second order, right? You have to integrate this term in this what second order. So let's integrate this in the second order. If I integrate sine 3x, okay, let's integrate sine 3x, and don't forget integrating sine 3x will give you uh cos cos 3s divided by 3, right? Because now integrating this, it will give me cos, yes, cos 3s, then I will differentiate this, which is 3x, then divide by what now? 3x. Are you there? Divide by 3. So it means if I integrate this in the first order, I will have cos or minus cos 3x all over 3, right? Then if I differentiate it again in the second order, it will now turn into cos, right? So if I integrate, okay, it's not cos, it's cos minus cos 3x all over 3, right? Then I'll integrate it again. The sign will now come back to, the cos will not turn back into sine again. So we have sine 3x divided by 3, because I will differentiate this again to give me 3. So I already have all over 3, then 3 multiplied by that 3 will give me what? 9. So it means I should have what? This term here. So to give me what? Sine 3x all over 9. And then for this, I have minus 2 cos s. I will integrate cos x, 2 cos s. So if I integrate this, it will give me minus, don't forget, when you are integrating cos, normally the first thing that you're supposed to know, when you are differentiating cos, it will give you minus sign, right? But now when you are integrating cos, it will give you plus sign, right? So if I integrate this, it will give me 2 cos s, right? To give me 2 cos s, and I have minus, so I will have minus 2 cos s, sorry, minus 2 sine x. Then I will integrate that sign again, it will now give me minus. So minus times minus will now give me plus, then I will have what? 2 cos x back. So it means the second order integration of this will give me what? 2 cos s minus sine 3x all over 9. So I integrated this in the second order, it gave me this. I integrated this in the second order, it gave me this. So we have another example, but for this is just 1 all over d. So it means it's the same thing. This is multiplying this, this is multiplying this, and this is what? Multiplying this, which is same as what? This. So if I integrate this, right, 2x square, then this have to increase to the power of 3, then divide by 3. So it means integrating this, I will have 2x cubed divided by 3, plus integrating a constant will also give me what? X multiplied by that what? Constant. So it means if I integrate this, I will have what? 5x, then plus 2 all over x. Don't forget the integration of what? 1 all over x is what? Ln x. So if I have 2 all over x, then it means I should have what? 2 ln x, which is what? This. So the integration of this gave me this. So also we have some other questions, or that some problems that you are supposed to go through also. So it means you open this bracket, so you differentiate this. Looking at this is what? Product of what? A product, right? You have x squared here, you have e to the power of what? 3x. So you differentiate this, just it's simple product, right? Product. And the we say the formula. This one easiest way to differentiate product is to use product rule. I will say for product rule we have what? V du dx plus u dv dx. Or you can, it's another simple way, if you don't want to use that formula, is just to come and say, okay, differentiate this and leave this constant, then differentiate this and leave the constant. So differentiating this, it will give me 2x, right? Then multiply by what? E to the power of 3x. then plus I will differentiate this. This will give me 3e to the power of what 3x, then multiply by what x squared. Then you can then what, open the bracket to add them. However, in our next video we'll be doing some theorems, about 3 theorems on how to simplify any expression that have what exponential, right? We have like 3 theorems. Made the first and the second theorem are mainly to what simplify what expressions that have what exponentials. The third one is to simplify what expression that have what sine or cosine. So stay tuned and try to watch the next video, because in the next video we will be solving an example like this, where you simply would apply what the theorem, because you applying the theorem will simplify the work for you. However, even without the theorem, you can simply apply what product rule here and it will give you what the same value. So for now, I'm going to end this video because I don't want it to be too long. So in our next video, try to continue in our next video, where we now see some of the theorems that you will need to simplify this for you. Bye, and don't forget to wait for the next video.